So in each of the classes, we would be solving various problems, right? And each of the problem would introduce you a new problem solving technique or some critical point that you need to remember while solving a problem, okay? So in this particular video, we would be solving two problems as shown over here. Number one is we need to find out the values of x when x to the power 201 is greater than x to the power 198. The second one is close by x to the power 201 greater than x to the power 197. Okay, so let's start with the first problem. X to the power 201 greater than x to the power 198. How do we solve it? First of all, this problem itself is in the polynomial form, right? So just a small manipulation and it's a polynomial that you get. Very easy. It's actually easy problem. You just need to remember one point. That's why I have taken it. What do you do now? I can write this as x to the power 198 into x cube minus 1 greater than 0. Okay, basically factorizing it or trying to get the roots of this equation. X cube minus 1, you can factorize it or you can break it up easily. You can write this as x to the power 198 x minus 1 and x square plus x plus 1 greater than 0. Now here comes the important point in this problem. Look at this term, x square plus x plus 1. Can you factorize it further? No, you can't. Then what to do? That's the key question. If you can't factorize. If you can't factorize a particular quadratic equation, there can be two things. Number one, there can be two irrational roots. Since the roots are irrational, that's why you are not being able to factorize. Or the other case, maybe the roots are not real. If you remember the quadratic equation curve, there can be a situation where the roots are not real. So what is happening over here? Just check, just verify whether this is a case of 1 or case of 2. So in this case, I can clearly see that the discriminant b square minus 4ac is less than 0. Verify it by yourself. This shows that this is the case of 2. Roots are not real. For x square plus x plus 1, the roots are not real. If the roots are not real, what do you do next? Think. If the roots are not real, there can be two cases again. Two cases. Either the quadratic function is always positive or it may be always negative. Something like this. So the plot of this function x square plus x plus 1 can be either like this or it may be like this. How do you find out whether this is always positive or always negative? Just verify by putting x equal to 0. Basically, find out whether this is the point where the curve cuts the y-axis or this is the point. If it's in the positive side, that means the function is always positive. This is the case of always positive. And this is the case of always negative. Here, if you put in this, if you put x equals to 0, you get the value of the function equal to 1. Just put x equal to 0 over here. This shows that this expression, this polynomial expression, x squared plus x plus 1 is always positive. Now, if you are absolutely sure that a particular expression is always positive, what can you do? You can remove that from the inequality, right? I can write this as x to the power 198 into x minus 1 greater than 0 without any problem. There is no loss of solution. This is absolutely correct. Okay. Had it been always negative, then what would you have done? In that case, even in that case, you can remove that expression, but you would have to flip the sign from, so for example, here it's greater than 0. If that expression had been always negative, you should have made it less than 0. Okay, I hope you understand that concept now. Okay, coming up to here, what do we find? We find that the roots are x equal to 0 and x equal to 1 for this polynomial expression. Then what? Now comes another interesting point. That is, there are total 198 roots at x equals to 0 for this function, 198. So, if I put this on the number line, 0 is a root, 1 is a root. But for 0, remember, the sign around it would not change. Why? Because you have even number of roots at 0. So, this is positive, this is negative, continues to be negative after 0. Now, you have to find out the zones where this expression is greater than 0. There is only one zone, which is right hand side of 1. So, x must be greater than 1, or you can write x belongs to 1, infinity. That's the solution for this inequality or the first problem. Hope this is absolutely clear. Okay, now let's take up the next problem. The next problem is very close by. Only thing is that the right hand side has 1 degree lower, right? Let's see what happens now. So I have the next problem, x to the power 201 greater than x to the power 197. Let's continue with the steps. Very easy to understand. Now what do you do? Simple. Next what? We have the final completely factorized form of this polynomial equation or polynomial function. Now observe this term x squared plus 1. This is also always positive, right? X squared is always positive, x squared plus 1 is always positive. So this quadratic equation x squared plus 1 is also of this form, which never cuts the x-axis. There is no real root and it's always positive. So you can remove it from the equation. I can write this as x to the power 197 into x plus 1 into x minus 1 greater than 0. Now what? The roots are 0, in fact minus 1, 0 and 1. How many roots at 0? 197 roots, which is odd. That means there will be a change in sign around 0, right? When it's odd, there will be a change in sign. So if I draw the number line, I have minus 1, 0 and 1. Next, this side is positive, negative. There will be a change in sign, positive and negative. Now I have to find out the zones where it's positive, right? So my solution, I'm directly writing down the solution now. You must be very comfortable with it by now. Minus 1, 0. union 1 comma infinity. So this is the solution to the second problem. Very simple problem, but this trick or this point needs to be remembered. There are two things that I showed. First of all, when an expression is always positive, you can remove it from the equation. Had it been always negative, then also you could have removed it, but by flipping the side. After that, check for the number of roots. We did it over here. I have two problems as homework for you. These are related to these two problems, but slightly complicated compared to what we did over here. You have to be a little bit careful with the polynomials that you get. So this is x to the power 201 greater than x to the power 196. I have reduced the degree by one more notch. And the second problem that I have for homework for you is this: x to the power 201 greater than x to the power 195. Solve them, both this, and if you are able to solve it, write in the comment box that you have been able to do it and give your solution. If you are unable to do it, then also comment. I would provide the solution to these problems as well. Okay. So see you in the next video with a new problem. Thank you.